Simpson's rule, the first piece of that, we're just going to write down the actual rule. You will not have to restate this on your quiz on Monday, but you're going to need to know it and use it because there is a Simpson's rule problem on the quiz. It says if the interval from A to B, notice it's brackets so it includes those endpoints, is divided into an even number. Even is very important there. You can't use Simpson's rule unless you have an even number of sub-intervals. Of an equal width, and we'll call the width delta x, change in x. Then your area, and again this is an approximation, the formula, this is the big part of this. You take delta x and put it over 3, and normally with Simpson's rule you don't have an equation. Well, you just have a chart of numbers, and so you're going to plug your y values off the chart into the formula. So when I say y sub 0, I mean the first y value. And then after that, you're going to alternate. The first and last numbers are just the regular numbers. Everything in between alternates between multiplying it times 4. So like the next y value gets multiplied by 4 and added, and 2. And you just keep going back and forth between multiplying the next numbers by 4 and then 2. It is, and you will end with a 4. We'll say y sub n minus 1, and then the last one, whatever it might be, is by itself again. So that's why it only works with even, because you have to end on that 4. N minus 1 just means 1 before the last one, the y value that's second to last. And I'll show you what I mean by those subintervals. On page, I'm not going to go through it all, but on page 231 and 232 in your book, they show you where Simpson's rule comes from. You're doing areas still, but they kind of run through and do a derivation of the formula. So if you're interested in that, you can take a peek at it. Otherwise, we're just going to know the formula. Okay? Do you have any questions there? Everybody got this down so we can do an example? All right. Now, on this part where we're finding, the first thing you have to do before you use Simpson's rule, you got to make sure that it's applicable. So we have to make sure that we have an even number of sub-intervals. So you're looking from 30 to 35 is one sub-interval. 35 to 40 is 2. And we have 3, 4, 5, 6, 7, 8. Or you could look at it, if you don't want to count up the sub-intervals, you should have an odd number, 6, 7, 8, 9, an odd number of numbers in your list, however you want to look at it. Because you take away one, when you count the intervals, there's one less than there are x's. You also want to look in this case and make sure that all your x's are jumping up an equal amount. And they are. What are they jumping up by? 5. So we say that delta x in this case is 5. That's all you look at to find delta x here. So we can go directly to the formula. We put delta x over 3 3. It's always over 3. And then we start plugging in y values. The first one, that 83, stays just 83. Then we start with 4 times the next number. The next number is times 2, and we alternate back and forth with 4s and 2s. So 4 times 68, 2 times 61, 4 times 49, 3 times 37, 4 times 31. Where did I get what? Oh, I'm sorry. I said 2 and wrote down 3. I'll fix it. I said 3? Okay, well, I was supposed to say 2. I don't know where it came from. But notice that this last one, Felix, this is the n minus 1. This is the second to the last y. It should always be multiplied by 4. What did you say? No, if the one before it is a 4, then you don't have an even number of subintervals and you can't use Simpson's rule. In that case, we would use trap rule. And I'll explain that a little bit more on the next problem. Then you just put it in your calculator. You will have to type this in. You don't really have a program for Simpson's rule because you'd have to type in just as much stuff in a program. You'd have to type in all those y values anyway. So you're just going to have to type it in, and somebody asked if you have to write it out. Yes, you do. So I can see what you're typing in there. Now, in this case, on this particular problem, we don't have a label. Your label is going to be, say, for example, if x was feet per second and y was seconds, if we add that in, then your label would be feet. You're going to multiply your units to get your label. One thing you have to watch for, and I think you've got room to add this in your notes, if the labels don't match, so I'm changing problems here. Let's say that we had the same list, but let's say that this was, I think I got those backwards up here. Shouldn't my y be, yes, I should have had these switched, I think. X would be seconds and y would be feet per second. So let's say that they give us that exact same list of numbers and they still say that x is seconds, but they say that y is feet per minute. Yeah, you have to somewhere in there divide by 60 to change your seconds into minutes, or multiply. Usually it's easier to divide. Now you can stick it in at the beginning. You know, you could take 5/3 times 1 over 60. That is usually the best place to do it so that you don't forget it, because otherwise you might work through the whole problem, write down your answer, and be done. But now it's not wrong if you wait till the end and take that 2280 and divide it by 60, whatever that would be. I think it actually comes out nice. 380, or just 38. That 0 wouldn't be at the end. And since we divided by 60, we would still have a label of feet there, because we changed our seconds into minutes. So watch for that, because it happens on your homework.